9.3.1 Geometric Sequences and Series. A geometric sequence is a sequence where the ratio of any term to the previous term is a constant, and the common ratio is the constant ratio in a geometric sequence. Geometric sequences model or can be modeled by exponential equations. A rule for a geometric sequence for the nth term will be given by a sub n equals a sub 1 times r, which is our common ratio, to the n minus 1 power. Remember, the common ratio is the ratio of a term to the previous term. Decide whether each sequence is geometric. If so, find the common ratio. So, meaning that it's geometric and that there's a common ratio means that the second term divided by the first term should be equal to the third term divided by the second term, which should be equal to the fourth term divided by the third term. So the second term divided by the first term is 2. Third term divided by the second term is 3. Okay, we already know the answer to this is no, there's not a common ratio. Our second example, we do 27 over 81, which reduces to 1/3. We do 9 over 27, which reduces to 1/3, and then the fourth term over the third term, 3 over 9, which reduces to 1/3, and then there's just 1/3, so yes, and the common ratio is 1/3. Please keep anything that does not terminate in fraction form. Last example, 50 divided by 40, oh no, the other way around. 40 divided by 50. 40 divided by 50 is 4/5. 32 divided by 40 is 4/5. 25.6 divided by 32. If you were to multiply the numerator and the denominator by 10 and then reduce, you would also get 4/5. And the same thing is true for 20.48 over 25.6. If you multiplied numerator and denominator by 100 and then reduced, you would get 4/5. So yes, and the common ratio is 4/5. It's a little bit harder to determine if you are missing terms in your sequence. So maybe one thing to do would be to assume that it is geometric, write the equation for it, and then see if it works with subsequent terms. So the equation for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. Our first example, our a sub 1 is 5. We don't know what r is, but we know that a sub 4 is 135. And so we have a couple points we can work with. So using our formula, a sub n is going to be our a sub 4 value. So we're going to do 135 is equal to 5 times r to the n, and n is the subscript for the value you're using. And for this one, we are using a subscript of 4. A sub 4 is 135. And so then we raise that to the 4 minus 1 power. So we have 135 equals 5 times r to the third. Divide both sides by 5. And we get 27 is equal to r cubed. We take the cube root of both sides of the equation. And remember, when it's an odd index, we do not have to worry about absolute value. We get r is equal to 3. So if this is true, then a sub n for this would be equal to 5, our a sub 1, times 3 to the n minus 1 power. So let's try this with the other point we have, 1, 2, 3, 4, 5, 6. So this is our a sub 6 value. So 1,215 equals 5 times 3 to the 6 minus 1 power. 1,215 divided by 5 is 243, which equals 3 now to the 5th power. And so we are taking the 5th root of each side of the equation. On the right side, we obviously just get 3. And on the left, if you did the fifth root of 243, you would also get 3. So yes, this works. The common ratio is, okay, I'm not sure where we got shut off there. So if we take the fifth root of both sides of the equation, the fifth root of 243 is 3, and then obviously the fifth root of 3 to the fifth is 3. So yes, it does work. The common ratio is r equals 3. Okay. So for our next example, we're going to try the same thing. We have an a sub 1 value equaling 160 and an a sub 3 value equaling 40. Using our rule for a geometric sequence, the one that's up here, the a sub n, we're going to be using our a sub 3 values. So we're going to say 40 is equal to a sub 1, 160, times r to the 3 minus 1 power, because we are using the third term in the sequence. So we divide both sides by 160, and that's going to be equal to r squared. 40 divided by 160 is 1/4. So that means that r is equal to plus or minus 1/2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. The fact that the first and the third terms are positive already should be telling us that we're not going to be using the negative of the 1/2, because if we go back into the equation, we would not get, we wouldn't get positives for both the odd a sub numbers and the even a sub numbers. So like a sub 1 and a sub 8 would not have the same sign if it alternated. So we're going to be using the positive for r. And so let's just double check with another term, the a sub 8 term, which we know is 1.25. So if we say that 1.25 is equal to 160 times r to the 8 minus 1 power. I'm just going to leave the decimal in the fraction for right now. And then that means, remember, r is 1/2, so I'm going to go ahead and plug the 1/2 in here to the 7th power. So I'm going to go ahead and get a decimal approximation for both sides. 1.25 divided by 160 gives me 0.007812, and 0.5 raised to the 7th power gives me the same thing, 0.007812. So we have shown that our equation works, so yes, and the common ratio is 1/2. You may have been able to tell that without using the formula, but the formula will work every time. Write the rule for the nth term of the sequence when you are given the following information, and then find a sub 8. So we're using a sub n equals a sub 1 times r to the n minus 1 power. We can see that our first term is a -8. Our second term is a -12, so we can figure out what r is by using the ratio of those two numbers. And that reduces to 3/2. So in our a sub n formula, we're going to write our a sub 1 value of -8, our r value of 3/2, and then that's going to be to the n minus 1 power. When we go looking for a sub 8, we just replace all of the n's with 8's. And we have -8 times 3 halves to the 7th. I'm going to use a calculator to get that number. And we get an a sub 8 value of -136.6875. Write the rule for the nth term of the sequence that we have here, which goes 7, 35, 175, 875, and find a sub 9. So we can get r just by doing 35 over 7, which is 5, and that makes sense. Our sequence is growing, and it's all positive. So our a sub n rule is going to have a sub 1, which is 7, times our r value, which in this case is 5, to the n minus 1 power. When we look for a sub 9, we're just replacing the n's with 9's. And so we end up with 7 times 5 to the 8th power, which is 2,734,375. One term of a geometric sequence is a sub 3 equals 5, and the common ratio is 2. Write a rule for the nth term. So we know what r equals, but we don't know what a sub 1 equals, so we need to solve for that. So a sub n equals a sub 1 times 2 to the n minus 1 power. We're going to use the point we have here, 3, 5. So a sub 3, which is going to be 5, equals a sub 1 times 2 to the 3 minus 1 power. So we have 5 equals a sub 1 times 2 squared, which is going to be 4. So our a sub 1 value is actually 4/5. So we write our rule, a sub n equals 4/5 times 2 to the n minus 1 power. And then, we just needed to write the rule for the nth term. So that is all we need to do for that one. One term of a geometric sequence is a sub 5 equals 10.125, and the common ratio is 3 halves. And we are going to write the rule for the 10th term. So, again, a sub n equals a sub 1, in this case, times 3 halves to the n minus 1 power. We're going to use the point we're given, which is a sub 5. So 10.125 equals a sub 1 times 3 halves to the 5 minus 1 power. So 10.125 is going to end up being divided by 3 halves to the 4th power, and that's going to be our a sub 1 value. So I'm going to throw that into a calculator just to make my life easier. And we get 2. So to do what we're actually told to do, which is write a rule for the nth term, we have a sub n equals 2 times our r value of 3 halves to the n minus 1 power. Okay, last example. Two terms of a geometric sequence are a sub 2 equals 45 and a sub 5 equals negative 1,215. Find the rule for the nth term. Remember that we're starting with a sub n equals a sub 1 times r to the n minus 1 power. We do not have basically, we do not have an initial condition to work with. Like we don't have what r equals, and we do not have what a sub 1 equals. When this happens, one of the things we can do is kind of create a system of equations. So we would have 45 equals a sub 1 times r to the 2 minus 1 power, because that's a sub 2's value. And then negative 1,215 equals a sub 1 times r to the 5 minus 1 power. So I'm just going to go ahead and rewrite these. 45 equals a sub 1 times r to the first power. negative 1,215 equals a sub 1 times r to the fourth. So if we could solve both of these for a sub 1, then we can set them equal to each other to solve for r and then back substitute. Because if a thing is equal to two other things, and those two things must be equal to each other. So that means that a sub 1 from our first equation, a sub 1 equals 45 divided by r. And then that means in this one, a sub 1 equals negative 1,215 divided by r to the fourth. So that means that 45 over r is equal to negative 1,215 over r to the fourth. So what we have now is an equation we can solve by cross multiplying. So we've got 45r to the fourth equals negative 1,215r. I'm going to bring everything over on one side and factor. Our greatest common factor is going to be 45r. That means we are left with r cubed plus 27 is equal to 0. So the 45r equaling 0 would mean that r equals 0, and that can't be the case because it wouldn't be geometric. Okay, so we'll take the other, because if you're multiplying by 0 each time, then the sequence isn't growing or decreasing. So that means we have r cubed equals negative 27. And if we take the cube root of both sides, which we can take the cube root of a negative, we get r equals negative 3. So now we know we have a common ratio of negative 3. And we can rewrite our rule now with a sub n equaling a sub 1 times negative 3 to the n minus 1 power. So we have to solve for a sub 1, which we haven't done yet. We can use either of our initial values, which I'm going to use the a sub 2 equals 45. So if I do 45 equals a sub 1 times negative 3 to the 2 minus 1 power, that means I have 45 equals a sub 1 times negative 3 to the first power, or 45 divided by negative 3 equals a sub 1. So a sub 1 is equal to negative 15. Now we are finally ready to write our equation. A sub n equals negative 15 times negative 3 to the n minus 1 power.